Okay, so how is it going so far in Newton's law of motion, dear? You're learning, you're enjoying? Basically, whatever we have studied up till now is pretty basic. The main topic of this chapter is constraint motion. That will come after we go through with spring force. Basically, we have dealt more with string force and tension up till now, so we should spend some time studying spring force as well. So we'll do that very quickly, and then we'll move on to constraint motion. So, spring force. We have already introduced ourselves to this before. Let's consider this situation. A block is hung from top via a string. Suppose this is of mass m, and another block of the same mass is hung by spring. Now the question asked is this: if we cut the string and the spring, then at that very moment we cut the string and spring, what will be the acceleration of this mass and this mass? This is asked to us. Now let's analyze. Let's draw the FBD of this block. Mg is acting downward and tension is acting upward. So the body is a stationary, tension should be equal to mg in order to have a static equilibrium for the body. Now the moment it is cut, tension will vanish, tension will become zero, and it will take no time for the tension to become zero. Because in throughout our study we have assumed that the string is unstretchable. It cannot be stretched. If it cannot be stretched, then the molecules, the atoms, they will not go far apart from each other. So the tension to become zero, it won't take any time, because it won't take any time for the molecules to come closer to restore the initial position. The molecule will not have to travel any distance because they have not gone any considerable distance apart from each other. And in the ideal case, we are assuming that the tension is completely non-stretchable. That means the molecule have not moved apart at all. So it has to travel no distance to come back to its initial position. So it will take no time. Time is not required because mechanical motion is not involved. Right? So tension will become zero instantly. So T will vanish immediately. There is only force mg downward and the acceleration will be g downward. Now in this case the string is literally stretched. Now and the force is because of that stretch, and the spring is stretched by a certain amount, and the spring force is by the virtue of that stretch. If the spring force has to vanish, then the stretch has to vanish. That means the particles, different part of the spring has to come closer, and that's going to take some time because the spring has to travel considerable distance. That cannot happen instantly. The time would be very, very less. It will be in the order of some picosecond or nanosecond, but still it's going to take some time. It's going to take some finite time. At that very instant the spring force will continue to exist even if you cut the spring. If you cut the spring will remain stretched. If it remains stretched at that very moment, then the spring force continue to exist. So in this case the spring force will continue to exist. So at that very moment the net force will still be zero. So acceleration will be equal to zero for the second case, because the spring force does not vanish immediately. That's the concept, and that's pretty easy to understand. So here is the important thing: the string force becomes zero instantly. A spring force does not become zero instantly. It's an important concept, and they have been asking questions over and over again on this concept. So we'll do some problems based on this. Let's try with this one. There's a block of mass m hung with a string, and there's a spring again, and there's another block of mass m. And you know what I'm going to ask. If you cut the spring if you cut the string from here, then at that very moment when you cut the string, find the acceleration of this block A and this block B. This is a pretty simple, straightforward question, and you should try your hand on this really. Get your answer, tell me what's your answer. What's the acceleration of block B and what's the acceleration of block A? The acceleration of block A, and I hope you got your answer already, will be equal to 2g downward, and the acceleration of block B will be equal to 0. Fine, you got your answer? Very good, you're doing very well in mechanics. How would that be? That be because the mass, this block B, it has a force downward mg and has a spring force upward. Spring force will remain. Spring force is not going to vanish. So spring force is there. So this body continues to be in equilibrium, and this body, this some force is vanishing. There was tension acting upward, there was mg acting downward, and the spring force is also acting downward. Spring force is equal to mg from the equilibrium of this body. So mg plus mg, 2mg is acting downward, and tension, which has to be equal to 2mg previously, now is 0. So there's net force of 2mg downward, so the acceleration will be 2g downward. No problem in seeing that? Okay. Then quickly, let us solve this one as well.